Right. So we start. So keep asking questions as and when required, because we won't go that deep. So this chapter will test your knowledge about, first thing is we need to understand about force. To understand about force, Newton's first law will actually tell you about force. But before that, since we are doing revisions, so we will take up our things like, what is the SI unit? The SI unit of force is Newton. Okay, written as N, and 1 Newton equal to a mass of 1 kg being accelerated with 1 meter per second square along the direction of force. Okay, ये सब चीजें देख लेते हैं. Number A, SI unit. Number 2, CGS unit. CGS unit is said to be dyne. Okay, 1 dyne is equal to, when a mass of 1 gram is accelerated by 1 centimeter per second square. This is 1 dyne. Based on these two, we say 1 Newton is equal to 10 to the power 5 dynes. Okay, so this is, in fact, we should first discuss Newton's law, then you should come to it. But since this is revision, so we'll go this way. Force is a vector quantity. Force is a vector quantity. So in vector, we write force as mass into acceleration. Mass into acceleration. So force will always act along the direction where acceleration, because if you see the product, mass is scalar, acceleration is vector. So force is always going to act along the direction of acceleration. Okay. If the acceleration is negative, that means from the perspective you are seeing force, the force is an opposing force to you, because that force reduces the velocity. है ना? जैसे अगर if there is a body out here with the initial velocity u, then if you give a force F to it, then after some times we see that the body's velocity becomes v, and the time taken from here to here, say the time taken is equal to t. तो हम क्या बोलते हैं? v minus u by t. This is given as acceleration. So this sort of force is going to increase the velocity. However, if the acceleration was negative, that force is going to reduce the velocity, like a braking force, retarding force, dampening force. These forces are going to reduce the velocity. ठीक है? ये था मोटा मोटी ज्ञान. Now let us come back to Newton's laws. इसके साथ साथ हम चले जाएंगे. Our next things will be the Newton's laws of motion. So I'm not going to cram around the definition of each one. You very well can cram it up from the book also. But the first law, always remember, now you all are matured students in mechanics. So the first law will actually define force. The birth of force, the concept of force comes from the first law. It says that, now try to see that baby definition which we always cram about. A body at rest remains at rest, and a body in motion continues to be in uniform motion in a straight line unless and until it is acted upon by a force to change its state of rest or uniform motion. So it defines force. What is force? Force is that sort of a disturbance which is going to kill the uniform motion of a body if the body was in motion, and if it was in rest, it will bring it to motion. So force एक तरह का hindrance है. Whether it is helping you or not, that's different. But it is such sort of an actor in the play that the play was going smooth with uniform motion, or the play was at rest. When this fellow came in, it changed the whole course of the play. That is the definition of force. So यहाँ से हम क्या बोलते हैं? The first law से we always say that whenever in any system, remember, this will help you in grade 11 also, you are able to identify a net force. When I say net force means in that system 4-5 forces act हो सकता है. मेरे कान को कोई इस साइड से खींच रहा है, इस साइड से भी खींच रहा है, सेम. Net force is 0. But if side से 3 Newton, इस side से 5 Newton, then it is actually pulling me 2 Newton this side. ये net force है. जहां net force है, this net force is that actor which changes the whole play. This net force जहां हो जाएगा, it will give birth to something called a net acceleration. अब आप जैसे सोचो, अगर आप force का direction ये है, then acceleration's direction will be this. If the acceleration's direction was this, then the force's direction is this. Net force will bring a net acceleration. And whenever acceleration takes birth, you know that velocity cannot remain constant. So velocity has to be two different velocities, one u and one v, and of this force to make this acceleration come into play and the velocities to change, this can't change just like that. There has to be some time which will elapse for this all changes to take place. सबको होने के लिए एक टाइम की जरूरत होती है, और अगर हम इन तीनों क्वांटिटीज को if we start equating them, then these give me my v minus u by t, this gives me my acceleration. That means all problems which are in a straight line, obviously you're in grade 9, so they will be in a straight line, which have a uniform acceleration and where force comes into play, can also be solved with SUVAT equations, SUVAT. So you don't expect a problem, you are going to get one problem. That one problem won't come from chapter 1. There are more chances it will come from chapter 2. Because in chapter 2, I can marry both concepts. So what happened? Angad is out of station or what?
Yeah.
All okay?
Sir, no. So he just said he's out of station.
Oh, why? Because suddenly in between he has gone out of station. That's what I'm saying. Okay, so this is the first law. First law gives you a defines force, gives you a definition of force. कि आखिर फोर्स होता क्या है, और जब हम फोर्स की बात करते हैं ना, we actually mean about the net force that is acting on a system, the net force. Then we come to second law. The second law will do what? The second law will quantify the second law is going to quantify force, or it goes to tell you, gives you a mathematical expression. It gives you a mathematical expression of what? Again, this net force. Second law ye karta hai. It gives you a mathematical expression of it. Okay. Now to understand second law, then what we need to do? We need to understand first a quantity which is known as momentum. ये जरूरी है समझना. Momentum is a vector quantity p which is said to be the multiplication of mass into velocity. So what is the direction of momentum? The direction of momentum will be same as the direction of velocity. What should be the unit of momentum? अगर mass kg में है, velocity is meter per second. Kg meter per second. Have you understood? So mass into velocity. चलिए इसको छोटा करते हैं थोड़ा सा, नहीं तो फिर we will not be able to finish up everything. Okay. So let's make this small. Let's put this here. So now we need to understand about momentum. So if you look at momentum, okay, P, I'm looking only at the magnitude part. P we say is mass into velocity. Obviously, in our all expressions or the study that we are doing, हमारे यहाँ पे क्या हो रहा है? Force is acting. So whenever force acts, force means net force. Please understand, force acts, velocity cannot be uniform. You will say, no, sir. Force is acting and there is a no. Whenever we speak about force means net force. If net force is acting, velocity cannot be uniform. Means if net force is acting, acceleration is into role. That means the velocity will again change into two different velocities. There was some initial velocity u and the final velocity v. And the study of grade 9 takes all our masses as constant. ये जो है ना, इसको हम constant मान के चल रहे हैं grade 9 में. We are not doing any problem where the mass is changing. Mass can also change. Rocket propelled upwards, it is losing propellant. Mass changes. Force is also there. Acceleration is also there. We are not going that deep. We are taking mass as constant, so velocity changes. If the velocity changes into v and u, then definitely for a u, the momentum also cannot be same. The momentum should also change to something called initial momentum and a final momentum, where my initial momentum will be given as mass into initial velocity, final momentum will be given as mass into final velocity. इन दोनों से हमें एक और चीज मिलेगा जिसको हम बोलेंगे डेल्टा p, which is change in momentum. That should be final momentum minus initial momentum. Do you get it? And this delta, this velocity, we always know that this changes over a period of time. If this changes over a period of time, that means this also changes over a period of time. That means this also changes over a period of time. So the quantity delta p over say delta t, that is the change in momentum over the change in time, right? Or we can also write this as delta p over t, where t I am saying as t is equal to delta t. T is the time, the change in momentum over change in time. The change in time is t. इसको हम बोलते हैं rate of change of momentum, rate of change of momentum, rate of change of mass, final mass minus initial mass, at what rate? Rate means always with respect to time, rate of change of momentum. तो इसकी डेफिनेशन क्या हो जाएगी? pf माइनस pi डिवाइडेड बाई t. अगर आप pf pi को करोगे तो ये क्या हो जाता है? mv माइनस mu डिवाइडेड बाई t, क्योंकि मास को कॉमन लिया तो v माइनस u डिवाइडेड बाई t, और ये हो गया m इंटू a. ये जो रेट ऑफ चेंज ऑफ मोमेंटम है, then this f net, कहां हमने पढ़ा था? ये f net, this particular fellow f net. The second law of Newton says that this f net is directly proportional to the rate of change of momentum. Directly proportional to the rate of change of momentum. That means my f net should be equal, directly proportional to m into a. Rate of change of momentum is ma. So in SI unit we write it as k into m into a, and k's value is taken as 1 in the SI unit system. Therefore f net is equal to m into a. So rather I will write it as a net, because f net brings an a net. This is the mathematical expression. यहीं से force का definition आता है. What is 1 Newton? 1 Newton force when acting on a body of 1 kg produces an acceleration of 1 meters per second square along the direction of force. The definition of force comes from here. What is 1 dyne? 1 dyne when acting on a body of mass 1 gram produces an acceleration of 1 centimeter per second square in the body along the direction of force. So the first law told me about what is the F net. And F net is created, always remember, whenever you are doing problems, first check. They will generally doesn't give you with two forces, but sometimes if the force is changing, first check what is the net force on the system. कभी दोनों साइड से खींच रहा है, right? They might give you that a body, a car which is being pushed by a force of 5 Newton is encountering a drag force of 2 Newton, constant force of 2 Newton. It is being pushed by 5 Newton, encountering a drag of how much? 2 Newton. During solving the problem, you should solve with 3 Newton only, because that is the net force acting on the car. If the drag was equal to 5 Newton, then the car would not have moved. And if the drag would have been more than 5 Newton, the car would have moved backwards. Clear है? तो आप हमेशा ऐसे प्रॉब्लम आने से नेट फोर्स को देख के कीजिएगा. So this is up till second law, right? Now second law को भी देखा, थोड़ा second law को भी छोटा करते हैं, ये पार्ट को भी, since we have understood this part also. How do I make it small? अरे घपला करेगा. Okay, so this part is also gone. Okay, now based on this, we again see this expression that the force acting on a body is equal to the rate of change of momentum, that is delta p over t. ये हमने देखा है ना, delta p over t. So if you see this time, ये time जो है ना, now certain examples will come where this time plays a very crucial role. Okay, now that karate guy who is breaking a lot of stones, how is he able to generate a lot of force? The change in momentum. The change in momentum means initially the hand was at a very high velocity, then the hand comes to 0 velocity. That change in momentum happens over a very small period of time. तो अगर आपका t reduce हो जाएगा, f का value increase हो जाता है. So this t is always small. Rather, you will later learn about a quantity f into t. This quantity is known as impulse. Impulse is basically same as change in momentum. देखो, change in momentum. Impulse is a force which acts on a body for a very short period of time. Cricketer, ball comes to him, he takes it in this direction. The reason is he is increasing the time. The cricketer is increasing the time. If he increases the time, then the force reduces. अगर वो time, क्योंकि बॉल को तो आके 0 होना ही है. पहले 5 सेकंड में 0 हो रहा था, अभी 7 सेकंड में 0 हो रहा है. तो हाथ में जो चोट लगेगा ना वो कम है, और अगर आगे ही जाके रोक लेगा कम, तो हाथ में चोट ज्यादा लगेगा. So many other examples, like somebody jumping on a trampoline and somebody jumping on a concrete floor. If you jump on a concrete floor, you are coming to 0 at a time, say 5 seconds. But if you jump on trampoline, you are coming to 0 at a time 7 seconds, 8 seconds. So t increases. As soon as T increases, F falls below. Therefore, you don't get the pain on your knees. ठीक है? Very bad example, but still, जो hanging by death by hanging जो होता है ना, the reason is this only. The momentum becomes zero over a very small time. The person is made to stand on a platform, and then immediately the platform is removed. So there are two types. One is called long drop and one is short drop. So in short drop, he falls and gets into zero at a very less amount of time because you're heavy. You'll ab niche गिर जाओगे. So it induces a lot amount of force which breaks your neck. Asphyxiation होके ये जगह choke कर देता है, and so death occurs immediately. Considered to be painless बोलते हैं. Not painless, less amount of time. So that was also same example. ठीक है? Are we fine till here? Rate of change of momentum. So we now go to the third law. तो थर्ड लॉ हमें क्या बोलता है? थर्ड लॉ में पहली बार न्यूटन के थर्ड लॉ में फर्स्ट टाइम a body is allowed to also exert a force. Till so much time there was only force acting on a body. Changes the state of the body from rest to uniform motion, rest to motion, or from uniform motion to non-uniform motion. Force acting on a body is directly proportional. Third law first time gives the body also to exert force. So when a body exerts a force on another body, the other body exerts an equal and opposite force on the first body. In such a case, जो चीज आपको आगे चल के याद रख के जाना चाहिए, थर्ड लॉ में हमेशा दो बॉडी होना पड़ेगा, बॉडी वन, बॉडी टू. Body one exerts a force on body two. This force is called an action force, and body two will exert a force equal and opposite, which will be known as reaction force. Okay, so if action force is represented by Fa in vector method, then this will be equal to the reaction force Fr, but with negative, because it tries to show that the reaction force is always in the opposite direction. Another thing that you have to always remember, action reaction always are of same nature. कभी भी अलग नहीं हो सकता है. If gravitational force is action force, reaction force also has to be gravitational. If electromagnetic force is action force, reaction force must be electromagnetic. If action force is muscular, reaction force should also be muscular. It has to be. Otherwise, they do not constitute a action-reaction pair. So when a body, don't write every body has an equal and opposite reaction. Every action has an equal and opposite reaction. When a body exerts a force on another body, the second body exerts an equal and opposite force on the first body. These two forces constitute what is known as action-reaction pair. Constitute what is known as action-reaction pair, and the action-reaction pair must be of the same nature, right? And I don't think collisions are there in your NCERT में तो collisions है नहीं, like momentum reduction and all, but we'll still solve some problems as per previous. Then comes, so that is the last part, which is known as the law of, I think this is no more there in your chapter. Okay, law of conservation of momentum. Okay, so if it's there, it's fine, but I don't think you have problems on collision and all. As per NCERT, anybody has the NCERT book? I said not to bring the NCERT book. Just check on force if we are leaving anything.
Sir, I remember.
She's opening it. Well, but do we have problems on this thing? We will do problems. It's not there. It has been removed now. Now it has been removed. Now they have made your chapter as very goody-goody. I'll tell you. The third law of motion is only the gun recoil. You don't have all these like car colliding law. No, we did.
No.
That's what I'm saying. Even in your school also, if you have done, the NCERT syllabus has now taken this off. This has now gone to grade 11. नहीं है, देखो. But we will do. No, we will do. That is not an issue. But the question is, the syllabus does not have it anymore. This is NCERT book. It has been taken off. It used to be there earlier. अभी और नहीं है. Science itself has become this much. Our physics is thicker than this. Okay, so law of conservation of momentum, which says that in this we actually try to solve problems. In these problems, you will always have what is known as an incident, and in that incident, you have to first identify the incident. Always remember that the momentum before the incident should always be equal to momentum after the incident. And with this, you can solve every problem. Make sure you take proper care of the signs, the way you're solving the problem. And when you're solving for mass, two bodies collide with each other and then go away separately. So there are two mass system, two mass forming one mass, combined mass system it can be. One body exploding into two bodies it can be. So make sure you're all having the correct application. Which side, say suppose, and the unknown velocity, you need not find the direction. It will automatically come out from your calculation if your calculation is correct. So how do we assume every velocity which is on the right hand side we take positive, every force on the right hand side will take positive, any force on the left hand side will take negative, any velocity on the left hand side will take negative. Bus. And remember one thing, two cars collide with each other and then get attached to each other.
Then
The mass is combined mass. Or a fragment broke into two, then combined mass split into two masses. This is what we need to remember. I don't think we have anything more than that. Now, do you have your what you call, the systems are there, so anyone can open. We can take up some questions also from there and do from there. Just 1 minute, kiddos. So just now it has arrived. The CPU of this panel has come just now. That's what I got an SMS. So we will migrate from this system and we will go into our Windows system. This becomes a computer now.
like
That is called an OPS. No, this is not SenseBoard. This is from Cornea. This is now behaving as an Android panel. This is just like an Android phone with a touching. Now we will end. Now out here we have got our facility for inserting the CPU. So we'll insert the CPU here. The CPU is this small. It's like a set-top box of Airtel that goes and slides inside here. That itself costs 30K around. That goes here, and then this becomes like a PC. Okay. Shall we start problems? So let's do some numericals. And we had a question paper, right? I'm not carrying whatever you have opened. You just tell which one have you opened, because is this much clear? Anyone has any understanding issue so far? So let's take up some problems and see whether you are. I'm not going to solve the whole problem. You help see whether you are able to understand the problem or not. So pick up one problem. देख लो, बहुत सारे क्वेश्चन है. पहले ऐसे कुछ प्रॉब्लम उठाओ. मैं बोलता हूँ पहले ऐसा प्रॉब्लम उठाओ. दीपांशु है क्या? ना ऐसे ही खोल के बैठे हो. हाँ, उसमें YouTube म्यूजिक और ये सब. ऐसा प्रॉब्लम उठाओ जिसमें b इक्वल टू यू प्लस एटी और एक्सीलरेशन के साथ है. स्काइप है बेटू उसमें. स्काइप में देखो तो. No, don't take MCQs.
Case-based question.
Case-based question will also not help. Case-based question you all try. Go to numerical. Do you have any numerical? Or else you go to the internet, na? Go to Google. Type laws of motion. Numerical laws of motion grade 9 PDF. You should get one. कुछ भी मिलेगा करते हैं. खुला. Next class से यही. I'll transfer my entire laptop data here, so we can open here and we can see anything that we want. That's why I ordered it with a higher gigs capacity. खुला. बोलो ना, एक क्वेश्चन बोलो. कुछ भी एक क्वेश्चन देखो वहां पे. क्या वो नहीं खुल रहा है तो बोलो, मैं हेल्प करता हूँ. Shall I open there? What guys? You all have browsing issues or what? How much time does it take? Tell me. Let's do one by one. Can I rub this one? Can I rub this portion? Can I rub this? Okay. Yeah, छोड़. हाँ, चलो इसको रब. चलिए. Tell me. Hey, no discussion.
Body mass 2.5 kg.
Okay, let's do a problem. It says a cat, right? So we have a cat. We have a cat. The cat's mass is how much? 2.5 kg. Okay, 2.5 kg.
Running.
Okay, it is running. The cat is running. And I don't know, I'll not allocate the narration for the velocity. I just say it's running at 2.2 meters per second.
Comes on the station skateboard.
Oh, very good. And then it comes and it jumps on a stationary skateboard. Wow. So this is the stationary skateboard. So this is two body system. So I would take the cat as say the skateboard is stationary. So the initial velocity of the skateboard, say us, is equal to 0, and the initial velocity of the cat, that is uc, is equal to this. How much is the mass of the skateboard? This is 0.5 kg. So it should break actually. 2.5 किलो का बिल्ली आके आधे किलो के ऊपर बैठेगा, कलाकार हो जाएगा इसका. So, okay, hang on. This is the mass of the cat and this is the mass of the skateboard. Now what has happened? Now the scenario is something like this. So this is the incident. The incident was what? The incident happened here where the cat has jumped over the skateboard. So now our cat is on the skateboard. Okay. So cat is on the skateboard. So what is the combined mass of the system? The combined mass will be the mass of the cat plus mass of the skateboard, which will be equal to 3 kg. Very good. What is the?
Will the skateboard move with the cat on it? If yes, find the velocity.
Okay, they're asking if the skateboard will move with the cat on it. If yes, tell the velocity. So we will now, we don't know anything. We will take that the combined masses, the combined body has a velocity v which is equal to unknown. Right. As per the law of conservation, what should happen? Momentum before. So what is momentum before? Mass of the cat into initial velocity of the cat plus mass of the skateboard into initial velocity of the skateboard. This fellow must be equal to combined mass into the velocity. In this problem, this part is straight away 0 because our trolley was at 0, right? So ये value कितना होता है जरा देखो, 2.5 into 2 which is equal to 5. In these problems, there is no issue to change any unit. सब अपने आप करता रहेगा. Okay, 5. 5 should be equal to how much? 5. So it becomes equals to 5 becomes equals to 3 into v. So our v should be equal to 5 divided by 3, which is equal to 3 1s are 3, 3 6 are 18, 1.67 meter per second. And what did we get as our sign of v? We got it as positive. So after the cat lands on, this system will now move with 1.67 meter per second in this direction. Why? Because we got the value of v as positive. समझ में आया? और ऐसे भी सोचो, कैट कैसा है? आप मोमेंटम देखो पहले, जिसका मोमेंटम ज्यादा है दादागिरी उसी का चलेगा. कैट का मोमेंटम कितना था? ज्यादा है. ट्रॉली का मोमेंटम तो ऐसे भी लड्डू है. So if it becomes a combined mass, who controls the combined mass? The cat will control the combined mass. तो उसी के डायरेक्शन में जाएगा. Understood how to apply? Nice and interesting problem. ठीक है, चले एक और करते हैं. Some again a different type, एक और लेते हैं. Then again we come to collision type. As so go on, you should have different papers also. It doesn't mind that what Piyusha has opened, you have to open. ये अपना पेपर खोलो, आप अपने क्वेश्चंस बोलो. इसमें तो सीखेंगे ना. क्या दिमाग से कुछ निकला उसमें या प्रेम पत्र निकल रहा है तुम्हारा? अच्छा बोलियो.
What is empty? Empty is a meter.
Empty.
Yes.
It's meter.
क्या उस लैंग्वेज क्या लिखा है पढ़ो?
MT equals
मीटर्स।
that's not.
हाँ मीटर्स है, क्यों बोलो, क्या पूछ रहे थे बोलो? वो मत करो, वो ड्राई पैच है उसको बार बार हाथ लगाते हो इसलिए और फिर चाटते रहते हो, वो और फटेगा। लिप बाम रखो और इसको लगाते रहो, ठीक हो जाएगा। दिल करता है ना बहुत इसको खरोचने का, जैसे मुझे भी ना टेंशन होने से यहाँ इच हो जाता है, मैं इसी को खींच देता हूँ चमड़ा, बड़ा प्लेजर आता है, उसके बाद इट स्टार्ट्स बर्निंग, मैं कोई खाना नहीं खा पाता हूँ। मत करो, मैं भी करता हूँ, नहीं करना है। क्या रखना है हाथ में? छोटा सा लिप बाम। लिप बाम लगा देने से आपको, और वो वंस इट बिकम्स ड्राई इट्स कॉल्ड चैप स्किन, वो बहुत आपको इच्छा करेगा ऐसा खींचने में, मजा आता है, फिर वही होगा। लिप बाम रखा कर छोटा सा। हाँ ग्लॉसी वाला मत लेना, फिर लोग सोचेगा लिपस्टिक लगा के घूम रहे हो। हाँ बॉल इज थ्रोन अप, दैट्स अ ग्रेविटेशनल प्रॉब्लम। इफ यू वांट टू डू आई कैन स्टिल डू, करना है तो। इफ यू वांट टू डू वी कैन डू, बोलो चलो करते हैं। हाँ करते हैं, आपको कोई इश्यू है तो करते हैं ना, इजी विजी। आप यू डोंट, यू आर नॉट द पर्सन टू डिसाइड इजी, दैट आई विल डिसाइड, यू टेल द प्रॉब्लम, विल डू। चलो करते हैं, आ जाओ। आई तो लव डूइंग प्रॉब्लम्स, टेल मी क्या है प्रॉब्लम?
33.
हाँ
Ball is thrown vertically upward.
अच्छा, ऐसे प्रॉब्लम में ये ड्राइंग ओरिएंटेड प्रॉब्लम है, चलो करते हैं। तो ये हमारे पास एक बॉल है और ये बॉल के साथ एक रेफरेंस जमीन होना चाहिए। बातें कम यार, इतना करते रहते हो, ये वेब अब ना आपको पुट स्टेपलर। हाँ ओके, आई विल पुट स्टेपलर। अ बॉल इज थ्रोन
Vertically upward.
ओके, वर्टिकली अपवर्ड्स। हाँ बॉल को हमने वर्टिकली अपवर्ड थ्रो किया। हाँ ये इंटरेस्टिंग प्रॉब्लम है, फ्रॉम द टॉप ऑफ अ टावर। ओके सो हाँ रुक जा, इसको हमने थ्रो किया है फ्रॉम द टॉप ऑफ अ टावर। हैंग ऑन ना, हैंग ऑन बेटा, इसको हमने थ्रो किया है फ्रॉम द टॉप ऑफ अ टावर। सो बॉल इज थ्रोन फ्रॉम द टॉप ऑफ अ टावर, टावर के ऊपर से फेंका है, ठीक है।
With an initial velocity of 19.6 meter per second.
19.6 क्यों दिया, समझ में आ रहा है? हाँ 19.6 देना मतलब एक इंटरेस्टिंग चीज है। हाँ और जी का वैल्यू में आराम से कट जाएगा। सो इट इज थ्रोन विद द इनिशियल वेलोसिटी, हाउ मच इज द इनिशियल वेलोसिटी? 19.6 मीटर्स पर सेकंड। आगे बढ़ियो।
It reaches the ground after 5 seconds.
इट रीचेस द ग्राउंड, इसका मतलब है कि ये बॉल जो है, ये बॉल एक मैक्सिमम हाइट तक गया होगा, है ना, यहां तक गया होगा मैक्सिमम हाइट, और मैक्सिमम हाइट जाने के बाद ये बॉल फिर कहां आ गया? ग्राउंड में आ गया, यानी कि द बॉल हैज कम हियर, और ये हमारा ग्राउंड लेवल है ना बच्चा, ये हमारा ग्राउंड लेवल है, ठीक है। सो इसका हम लिखेंगे क्या, राइट, इसका टाइम ऑफ फ्लाइट, टाइम ऑफ फ्लाइट, और ये टाइम ऑफ फ्लाइट में ऐसे टोटल लिख दूंगा क्योंकि दोनों टाइम मिला के कितने में आ गया वापस? 5 सेकंड्स, 5 सेकंड्स में। अच्छी बात है। फिर
Calculate one the height of the tower.
कैलकुलेट, हमें कैलकुलेट करना बोला है हाइट ऑफ द टावर। अच्छा अच्छी बात है। ओके सो वी हैव टू कैलकुलेट व्हाट इज द हाइट ऑफ द टावर, यानी कि टावर की हाइट कितनी है। ओके वी हैव टू कैलकुलेट द हाइट ऑफ द टावर एंड द वेलोसिटी विद व्हिच द बॉल स्ट्राइक्स द ग्राउंड, है ना, ये फाइनल वेलोसिटी। और फाइनल वेलोसिटी याद रखिए नीचे की तरफ आ रहा है, फिर ओके कैसे करेंगे इस प्रॉब्लम को? डोंट सी द सॉल्यूशन, इज द सॉल्यूशन देयर? हाँ देन बंद करो उसको। हाँ हाँ, a solution means the value is there, workout is there or what?
Very close.
Very good, keep it open, otherwise if the solution is there. Now how to proceed for this problem, who will tell me कैसे proceed करें? Don't try to fit formulas and all, how to proceed in this problem. हमें इसका हाइट निकालना होगा। सबसे पहले ऐसे याद रखिए, ऐसे सिनारियों में एक चीज जो हमेशा होने वाला है, ये पूरा कांड कहां पे हो रहा है? ये पूरा कांड अर्थ पे हो रहा है, वेरी गुड। और अर्थ पे एक चीज हमेशा, अभी अंगद होता तो बोलता सर कैसे नीचे की तरफ, चलो अंगद नहीं है तो कोई चांस नहीं, एक चीज नीचे की तरफ एक्ट कर रहा है वो है जी, जो कि है 9.8 मीटर पर सेकंड स्क्वायर। ये हमेशा नीचे की तरफ एक्ट कर रहा है। और ये जी क्या है? ये जी और कुछ नहीं, इस प्रॉब्लम का एक्सीलरेशन भी है। मैं प्लस माइनस कुछ नहीं लिखा हूं। हाउ टू डू दिस प्रॉब्लम?
So for the top height, when the ball is at the tower, we throw down. The velocity at the final position there.
Okay, so he's trying to say that at max height, what he's trying to say, at max height the velocity will be 0. Fair enough, understood.
This
acceleration is always downwards.
and,
Initial velocity, you know, so you will get the height. So what he's trying to say is that, he's trying to say that this is at the topmost position, so I'm putting a vt. So he's trying to say that he will use the equation vt square is equal to u square plus 2 g हमेशा negative है into the max height. Is this what you're trying to say? He's trying to say this into the max height. Okay, into the max height. He's trying to say this. Nothing wrong. Nothing wrong. But in that case, you will end up finding this height. What has been asked to you? Tower height. Then you will again start that this is 0 from here. Initial velocity 0, ball descends. आप एक चीज अप्लाई क्यों नहीं कर रहे हो? Whenever we say that v square is equal to u square plus 2as, can you tell me what is v in this expression? Forget this problem. Final velocity. What is u? What is 2? A scalar multiple. What is a? The uniform acceleration involved in the problem. In this problem is a uniform acceleration involved? Yes. G. ये क्या है?
How much distance? Displacement.
Displacement बोले तो क्या है?
Straight line distance.
Shortest straight line distance between initial and final. Why are you going for this motion? You can calculate the problem from here to here also. Displacement is the shortest straight line distance between initial and final. What was your initial position? What is your final position? We can apply. यही तो मैकेनिक्स का मजेदार चीज है ना। आप जो कर रहे हो वो रॉन्ग नहीं है। इट्स अ लेंथी प्रोसेस। Is this my final position? What is the displacement? Shortest straight line. So let's apply. It will be v square, which, and automatically the answer will come correct. You need not worry. V square, we know what is the value of v. We don't know what is the value of v square. So we're putting v square, okay? But ideally I should get what v square as? Negative आना चाहिए. V should be negative, but so v square I'll get positive only. Try and understand mechanics. V should come negative because ball is coming downwards, but we are solving from v square, so we should get positive. Agreed or not? Right. V square is equal to u square. Is the value of u square given to you, beta?
Yes, sir.
What is the value of u square given to you? 19.6. 19.6 से आपने बॉल को किधर मारा था? इधर देखो, इधर 19, वो छोड़ दो उसको। 19.6 से बॉल को कहां मारा था? ऊपर की तरफ मारा था। तो u आपका क्या था? पॉजिटिव था। वैसे कोई फर्क नहीं पड़ता है क्योंकि आप u स्क्वायर कर रहे हो। सो 19.6 square plus 2. Now comes the value of a. A is always negative. हमेशा ही नीचे आ रहा है। मैं ऊपर जाऊं नीचे जाऊं उससे कोई मतलब नहीं है। G is always negative because my problem works on Cartesian coordinate system where everything upward is positive, everything downward is negative. And where is the problem starting from? Here or here? From the top. So this is my origin. Anything from top from here is positive. देखो अपने आप आंसर मिलेगा. 2 into negative 9.8. Clear? Now into S. This is very interesting. S means here shortest straight line distance, which is nothing but the height of the tower. What about the sign? I told you, where has the problem started from? It will be negative. The problem started from the origin. And the displacement is more southwards. देख तो मैच हो गया सब। What is this? Another
And
19.6.
we can take 90.6 count.
ठीक है, another 19.6, and then this is age. Now, do you know the height?
Sir, 90.6 into 90.6.
19.6 into 2g. क्या लिख दिया गलत मैंने? एक मिनट हाँ, v square equal to u square. हाँ, u square is how much? 19.6 square plus 2as. हाँ, क्या गलत लिखा?
You didn't check this square.
Where I didn't try the square? अच्छा, second वाला पे. हाँ, so how do you find the h now? You don't know the v.
Sir, V is 0.
How can v is 0? V cannot be 0. Final velocity is never 0. First find t. How will you find t? ऐसे नहीं जाएगा. ये देखो, जब आप करोगे प्रॉब्लम तब आप सीखोगे. तो इसमें आपको क्या इक्वेशन पहले लगाना चाहिए? फर्स्ट इक्वेशन यू ट्राई टू पुट इज दिस इक्वेशन, s equal to ut plus half at square. Just check in this question, do you know the value of t?
No, sir.
तो कैसे होगा?
Sir, we have U and A.
Two unknowns are there. How will you find out? कैसे निकालेंगे? क्या करोगे? सोचो सोचो सोचो. हाँ.
When you threw it up,
हाँ.
19.6. वो 2 सेकंड की है, 2 सेकंड के बाद उसको
नहीं, उससे कोई मतलब नहीं है. वेलोसिटी देखो, एक और चीज होता है, अंडर द एक्शन ऑफ ग्रेविटी ऑलवेज रिमेंबर टाइम ऑफ असेंड इज इक्वल टू टाइम ऑफ डिसेंड. दैट इज टाइम टेकन टू गो अप एंड द टाइम टू कम टिल हियर, नॉट नीचे तक का. आपको टी दिया है ना 5 सेकंड्स, यू आर नॉट कैलकुलेटिंग. सोते हो प्रॉब्लम में. व्हाई डिड यू यूज दिस 5 सेकंड्स? यू ऑल आर स्लीपिंग. गेट इनटू द प्रॉब्लम. नहीं चाहिए नहीं, हमारा उसी से आंसर आएगा, उधर से उधर से इधर से. आ जाओ, चलो. s इज इक्वल टू ut प्लस सॉरी हाफ एटी स्क्वायर. इस इक्वेशन को फिट करो यहाँ पे. अगेन प्रॉब्लम स्टार्ट्स फ्रॉम वेयर? द ओरिजिन, एंड यू आर गोइंग योर s इज डाउनवर्ड्स. वैभव, मैं खिड़की खोल के बाहर फेंकूंगा. What didn't say? You have made an I expression to him just now. Yes or no? You made an I expression. Whether he is responsible or you are responsible, I don't know. When the moment I saw, you were. It's like a police raid. When I raided the premises, I found you. Now court will decide whether you are. Yeah, ना? Yeah, interesting. इसको fit करो ना इस equation को. Let's learn something. क्यों इतना fickle minded हो जाते हो? चलो, fit it. How will you fit it? Scale and all you leave. You try to fit. What will be your s in this case? S is the height of the tower. See how absent-minded you have become. S is the displacement. The displacement is the height. But what do I take the sign of height as?
Negative.
Negative. So right, negative height of the building is equal to u. What is the value of u? Positive u. इधर देखो ना, क्यों लिखना शुरू करते हो? मुझे हेल्प करो तो सीखोगे. 19.6 into what? 5 seconds plus half. What is the value of a? Minus 9.8 into t square. That is 25. Have you understood? Do you get the value of h from here?
But how 5 seconds? 5 seconds तो ऊपर जाके नीचे आने.
जैसे जहां आने में जाने में लगे. यही तो मजा है प्रॉब्लम का. जहां लगने दो, हमें उससे क्या लेना देना. हम तो डिस्प्लेसमेंट देख रहे हैं. आप करके देखो, आपका आंसर सेम आएगा. अगर आप विश्वास नहीं कर रहे हो, यही ब्यूटी है. गुड यू रेज दैट क्वेश्चन. हमें 5 सेकंड से क्या लेना देना. हमारे इस डिस्प्लेसमेंट को होने में फाइनली कितना लगा? 5 सेकंड. डिस्प्लेसमेंट को टाइम से कोई लेना देना नहीं है. यही तो होता है ना. यहां से यहां का डिस्प्लेसमेंट टाइम डिपेंडेंट नहीं है. हमें कुछ लेना देना नहीं है. अब उल्टा यहां से देखो. अब जस्ट सी फ्रॉम हियर, 19.6 into 5, इसको आप 20 मान लो. 20 को 5 से करोगे तो कितना आएगा? 100 आएगा, है ना. और ये कितना है? 25. 25 को अगर आप 10 से मल्टीप्लाई करोगे तो 250, उसको हाफ करोगे तो 125, तो ये आंकड़ा बड़ा आ रहा है। अल्टीमेटली ये चीज नेगेटिव हो जाएगा और ये भी नेगेटिव है, तो एच पॉजिटिव हो जाएगा। मन को शांति मिल रहा है कि नहीं? आर यू गेटिंग व्हाट आई एम ट्राइंग टू से? ठीक है, तो चलो इसको कैलकुलेटर यूज करते हैं फटाफट करने के लिए। आओ, let's use calculator and do this thing quick. Okay, so we are having how much? We are having 25, and that's being multiplied by 9.8 and is being divided by 2. So this is 122.5, which is negative 122.5. Do you agree? और इधर कितना है? 19.6 into 5, यानी कि 19.6 into 5. So ये क्वांटिटी है 98. कितना हो गया? 98 minus 122.5, 24.5 आया नेगेटिव, और ये नेगेटिव एच, तो एच की वैल्यू कितनी आई? 24.5। मैं चाहता हूं आज आप घर पे आपकी तरह से भी करके देखो, वही आएगा। यकीन नहीं है तो आएगा, वही आएगा। ये समझ में एच हो गया हमारा। अब और क्या निकालने बोला है? वी। तो वी तो आपको पता ही है, वी स्क्वायर इज इक्वल टू यू स्क्वायर प्लस 2as, यानी कि आपका वैल्यू कितना होना चाहिए? रूट ऑफ u का स्क्वायर बोले तो 19.6 का स्क्वायर प्लस 2 इंटू निगेटिव 9.8, और s कितना है? निगेटिव 24.5। ये h की वैल्यू है हमारी। ठीक है, another thing, sorry, I made a small mistake. You need not take h as negative when you start the problem. You'll take h as h only. Sorry, huh? You should get your answer as negative. Sorry, this is a small mistake from my side. If anyone has a confusion, just ask me. आपको h का वैल्यू नहीं दिया हुआ है ना, तो आप इसको, सॉरी, हाँ, तभी ना प्रॉब्लम करेक्ट हुआ है। सॉरी, वेरी सॉरी। You will take this as positive and you got the value of h as negative. You say h is equal to negative 24.5, means height is equal to 24. h is displacement downwards, तो ये नेगेटिव है, करेक्ट है। हाँ, तो अभी हमने यहाँ पे नेगेटिव ले लिया है h की, because this is the value of h. You'll go h as negative only. So let's solve this. कितना आया? 24.5। बहुत बढ़िया। 24.5 is being multiplied with 9.8, right? And you are adding it with the square of 19.6 का square, so 624, और इसको x to the power y 0.5, oh sorry, so 19.6 इसका square is added to 24.5 into 9.8, so 624.26, and x to the power y, sorry, 624.26 x to the power y 0.5, 24.99 के आसपास है, 25 के आसपास। कितना है आपको दिवांशु?
68 points.
नहीं, फिर से चेक कर, रूट है।
So like in the first formula,
फर्स्ट फॉर्मूला मतलब
v is equal to
u प्लस 80। हाँ, वो करने से भी आएगा।
no sir 68 points.
हाँ, गड़बड़ हुआ है। वन मिनट, this one, this no, I'm saying this calculation. हाँ, so where are we going wrong? Oh, correct हो आप, हमने ये 2 को यूज नहीं किया ना। I am wrong. Correct. How much you all got? 68 point. हाँ, चेक करते हैं, ऐसे माना चाहिए। ये गलत आंसर है। एक मिनट रुको। 24 पॉइंट, ये बोलो तो कितना है? 24.5 इंटू 9.8, 240 इंटू 2, 480, प्लस 19.6 का स्क्वायर which is 864, बिल्कुल करेक्ट, 864.36, so it is 864.36 x to the power y 0.5, 29.4. कुछ तो एक गड़बड़ हो रहा है, 1 minute. Into 8 into 4.5, 864, 666, 6. This is v square equal to u square plus 2as. क्या गलती हो गया है? मुझे गलती हुआ है. Cannot be two different answers. u plus 80. इसका रूट अगर हम करें I'm still getting 29.4. Where have we gone wrong? U plus 80. ए, पीटूंगा ना पकड़ के तुम लोगों को. कैसे तुम लोगों का आंसर आता है? दोनों को पकड़ के पीटना चाहिए. तो खुद गलत करते हो, मेरे को भी गलत कराते हो. ये इसका आंसर आएगा. दिस आंसर इज 29.4 मीटर पर सेकेंड. और ये नेगेटिव, मतलब आपका v is the magnitude of v is this, but if you ask me in direction you should get negative 29.4 meter per second. दीपांशु, v is equal to u plus 80. u का वैल्यू कितना है? 19.6. a का वैल्यू कितना है? minus 9.8. sorry, no, that's what, that is over excitement. So minus 9.8 into 5. 29.4 नहीं, negative 29.4 आएगा. गलत हो ही नहीं सकते. नेगेटिव मतलब बॉल नीचे की तरफ आ रहा है. और मेरे आंसर में क्या आया है? v स्क्वायर इज इक्वल टू, रुको रुको रुको, मैकेनिक्स का मजा लो. डोंट स्टार्ट सॉल्विंग यार, आई हेट दैट. एंजॉय. हैव वी गॉट आवर फिगर्स सेम? बट स्टिल यू हैव गॉट द राइट साइन. व्हाट अबाउट मी? यू विल से सर यू गॉट पॉजिटिव. नो, सर हैज डन अ रूट, सो सर's आंसर इज एक्चुअली इन प्लस माइनस. एंड व्हिच वन सर शुड अडॉप्ट? नेगेटिव वन. व्हाई? बिकॉज द बॉल इज कमिंग डाउनवर्ड्स. ये होता है फिजिक्स. आंसर अलग हो ही नहीं सकता है. एक तो खुद कंफ्यूज हो गया मुझे. हाँ बोलो यथार्थ, बहुत कुछ तुम्हारे दिमाग में घूम रहा है. पूछो पूछो, निकलना है. आप 11 में कहीं और पढ़ोगे, लेकिन मैं ये नहीं चाहता हूं कि आप टेंशन के साथ जाओ. बोलो.
Not zero, but the tower level is zero.
जब मैं आपको 14th फ्लोर से नीचे फेंक दूंगा ना, आपका फाइनल वेलोसिटी कभी भी जीरो नहीं है. फाइनल वेलोसिटी इज द वेलोसिटी जस्ट एट द इंस्टेंट बिफोर स्ट्राइकिंग. स्ट्राइक करने के बाद आप ऐसे आके रेस्ट पे आ गए, पर आपका फाइनल वेलोसिटी जीरो नहीं है. आप पहले चीज समझिए. अगर मैं ऊपर से एक बॉल को रिलीज करूं, इनिशियल वेलोसिटी जीरो. अगर मैं थ्रो करूं, देन इनिशियल वेलोसिटी हैज अ वैल्यू. आर वी परफेक्ट ऑन दिस टू अंडरस्टैंडिंग? मैंने नीचे से एक बॉडी को ऊपर फेंका. इनिशियल कैन नेवर बी जीरो. इफ इनिशियल इज जीरो, बॉल विल नेवर गो अप, इट विल गो डाउन. सो इनिशियल वेलोसिटी पॉजिटिव. Final velocity at maximum height 0. Then ball starts gaining. So initial velocity of the ball at that time will be again 0, because at the top nobody is throwing the ball down. The ball just falls under gravity. Yes or no? Please understand. आराम से हमने बॉल को ऊपर की तरफ उछाला. Initial velocity positive. Ball reaches maximum height. Final velocity 0. 0 होने के बाद बॉल नीचे गिरेगा. उस वक्त इनिशियल वेलोसिटी कितना है? 0. एंड देन बॉल नीचे आके गिरेगा. फाइनल वेलोसिटी इज नेवर 0. फाइनल वेलोसिटी इज अ वेलोसिटी विथ व्हिच इज स्ट्राइकिंग द ग्राउंड. तभी ना वो अपना काइनेटिक एनर्जी इंपार्ट करेगा ग्राउंड को. अगर बड़ा सा पत्थर है तो कौन फटेगा? ग्राउंड फटेगा. ग्राउंड क्यों फटता है? लॉट ऑफ एनर्जी इज इंपार्टेड टू इट. हु इज ब्रिंगिंग द एनर्जी? बॉल. हाफ mv स्क्वायर. and the kinetic energy goes on increasing as you are coming down. Initially everything is magaha, mgh. mgh starts transforming into half mv square, half mv square, half mv square. H is reducing, h becomes 0, all potential energy gone. What is with me? Kinetic energy. Energy can neither be created nor be destroyed. मारो एनर्जी गए हो कि तो काइनेटिक एनर्जी बन गया. काइनेटिक एनर्जी किससे बनता है भाई साहब? हाफ इंटू एम इंटू वी स्क्वायर. हाफ तो भगवान ने दे दिया है, एम तो हमारा कभी जीरो हुआ नहीं, तो वी स्क्वायर तो होना ही पड़ेगा ना मेरे अंदर. वी स्क्वायर है मेरे अंदर, पर वी की जो साइन है वो नेगेटिव है. नेगेटिव को स्क्वायर करोगे तो पॉजिटिव ही है. इफ यू यूज दिस इक्वेशन, which was a smart move by you guys, I should have, that was idiotic on my part that I went by the tougher one. You went by the, you need a calculation mistake and you spot on got a negative answer. Absolutely right, your velocity is downwards, negative, correct. I went with a square. You will think I am getting positive. No, a square's answer is both positive and negative. It's my choice which to keep and which to discard. I will now keep the negative. Here also height I got negative, which is very correct because the displacement is downwards. Height is same as displacement in magnitude. Please understand, आपको बिल्डिंग का क्या निकालने बोला? हाइट. आपने मैग्नीट्यूड निकाला. 2000 I was born, 2015 में you were born, 2015 में मेरा एज is equal to your difference from 2000. एक ही बात है ना. So you are trying to find the displacement. The displacement is equal to the height in magnitude. तो ये जो h है, this is nothing but the displacement. आप इसको s करके सॉल्व करो ना, आप h मत करो s. आप फिर एक लाइन लिखो, the s is nothing but the magnitude of s is nothing but the height of the building. So what is the height of the building? 29.4. What is the displacement? Negative 29.4. Still if there is query बोलो और आंसर करेंगे, लेकिन प्रॉब्लम का मजा लो, आंसर तो मैच करेगा. और दिवांशु आप इसको ऐसे ऐसे करके भी देख लो. In fact, in grade 11, when you see projectile motion, they will give you problem like this. See, a ball is thrown and the ball falls like this. Initially, all grade 11 students will calculate here to here to here. I can open the grade 11 book and right now show you. That is foolishness. We're supposed to solve only from here to here. Displacement ना. आप कैसे गए? उससे मुझे कुछ नहीं लेना देना.
डिस्प्लेसमेंट
ये इसको तो मैं आपको 2D में ड्रॉ करके दिखा रहा हूं ना. शॉर्टेस्ट स्ट्रेट लाइन डिस्टेंस, ये तो सीधा ही गिरेगा, हवा चलेगा तब ऐसे आएगा ना. समझ में आ रहा है? चलो एक और प्रॉब्लम किया जाए. Have you understood this? But this was not from this chapter. This is generally from gravitation. हाँ चलो और बोलिए. लेकिन सारे प्रॉब्लम में तुम अभी भी डायग्राम नहीं बनाते हो. डायग्राम नहीं बना, वो डायग्राम ही नहीं है. डायग्राम नहीं बनाने से आप फिजिक्स नहीं समझेंगे, कभी नहीं समझेंगे. एक प्रॉब्लम होगा, वो कैट और ट्रेलर वाला प्रॉब्लम कितना क्लियर होता है देखो जब आप डायग्राम्स ड्रॉ करते हो. डायग्राम इज मस्ट. बोलिए. हाँ, एक हमारे पास क्रिकेट बॉल है, इसका मास कितना है? हाउ मच? 0.20 kg. 1.2 मीटर पर सेकेंड. हमने अभी यूवी नहीं बोला, सुन लेते हैं प्रॉब्लम को. फाइंड द इम्पल्स ऑन द बॉल. हमें बॉल पे इम्पल्स निकालने बोला है. सबसे पहले तो इम्पल्स को देख लो. इम्पल्स कहां से आता है? फोर्स इक्वल टू चेंज इन मोमेंटम ओवर स्मॉल टाइम एंड दैट फोर्स इनटू टाइम. ये जो है ना, इस क्वांटिटी को इम्पल्स बोला जाता है. तो इम्पल्स कैसे निकलेगा? या तो somebody has to give me force and time, or by change in momentum I will be. But in this problem it will be by change in momentum because already the mass is given, already the velocity is given. Find the impulse. बोलो. If he is able to stop the ball in, ball यहाँ पे रुक गया, velocity कितना हो गया? 0 meters per second. तो इसको भाई साहब यू ले लेते हैं और यहां से यहां तक कितना टाइम इलैप्स हुआ? What is the time elapsed? 0.10 seconds. बस सब दे दिया आपको. आपको क्या क्या निकालना है? इम्पल्स और फोर्स. फोर्स कैसे निकालोगे बोलो? फोर्स कैन बी फाउंड आउट बाय चेंज इन मोमेंटम. व्हाट इज चेंज इन मोमेंटम? फाइनल मोमेंटम. देखो कितना, लुक एट दिस प्रॉब्लम, हाउ ब्यूटीफुल द आंसर विल कम. लुक एट द फाइनल मोमेंटम इज ऑलवेज 0. माइनस इनिशियल मोमेंटम। इनिशियल मोमेंटम कितना आएगा? 1.2 इंटू 0.2 कितना आएगा? 1.2 1.2 से करो, 1.2 12 से कर देते हैं। 12 इंटू 0 इज 0। 12 टू से कितना होता है? 24 and 12 zeros are 0. How many points? 2 and 1 3, so 0.3. So this divided by, what is the time? 0.1. So our force is coming negative 0.24 divided by 0.1, है ना? तो इसको 0 कर लिया, दोनों कट गया, तो फोर्स आया नेगेटिव 2.4 न्यूटन। नेगेटिव 2.4 न्यूटन आ रहा है। ध्यान दे इस फोर्स को, कितना आया? नेगेटिव। और एकदम करेक्ट है क्योंकि प्लेयर ने बॉल को रोका है, सो प्लेयर मस्ट हैव अप्लाइड अ फोर्स व्हिच इज नेगेटिव। हम गलत है ही नहीं। और क्या निकालने बोला है? इंपल्स। नाउ वी आर फोर्स नेगेटिव, द फोर्स इज कमिंग नेगेटिव, तो आप क्या लिख दोगे? अ फोर्स ऑफ मैग्नीट्यूड 2.4 न्यूटन is acting opposite to the direction of the ball to bring it to rest in 0.10 second. Now we need to calculate the impulse. Impulse is what? Force into time. अब लेकिन फोर्स को हम नेगेटिव नहीं लेंगे, अब हम पॉजिटिव लेंगे, because we are supposed to only tell the impulse on the ball. So what is the impulse? Force is how much? 0.24 into 0.10. तो ये हमारा, ये क्वांटिटी बन जाएगा हमारा impulse. This quantity will become our impulse. Why did I take positive now? Because we are just calculating what is the impulse on the ball. Now direction has nothing role for me. ये नेगेटिव या पॉजिटिव फोर्स को घटाता बढ़ाता नहीं है, ये सिर्फ ये बताता है सब्जेक्ट इतने दिनों से बात नहीं कर रहा है। सब्जेक्ट कौन था? आनंद भाई, है ना? तो सब्जेक्ट के ऊपर किस साइड से फोर्स लग रहा है वो आपने देखा। अब सब्जेक्ट पे कितना है? What is the impulse on the subject? आपको किसी ने बाएं साइड से थप्पड़ मार दिया, -5, और 2 सेकंड के लिए थप्पड़ लगा, सो -10। इंपल्स आपको लगा है 10 न्यूटन सेकंड का है, बट द डायरेक्शन ऑफ फोर्स दैट वाज नेगेटिव 10 न्यूटन, बाएं साइड से थप्पड़ लगाया। खत्म। क्लियर? Who did not understand this problem? Is there any cough, any bacteria, any sort of throat disclarity? देख यथार्थ तेरा मुंह कैसा हो रहा है, तू पूछ ले, कुछ गड़बड़ है तो इस प्रॉब्लम में। हाँ, थिंक करना, बोलना, वो मेरे साथ डिस्कस करना। नहीं, मेरे साथ डिस्कस करना। क्यों, क्या जाता है? इंपल्स स्केलर नहीं है, वेक्टर है। हाँ, क्योंकि उसका फोर्स ही तो, इंपल्स स्केलर नहीं है। और बोलो क्यों नहीं हो सकता इंपल्स स्केलर? देखो और भी देखो, अगर आप F इंटू टी करते हो तो उस साइड में क्या मिलता है? डेल्टा पी। ये अगर सक्रिय है तो ये भी सक्रिय होना ही पड़ेगा ना। बात समझ में आई? मोमेंटम इज वेक्टर, सो चेंज इन मोमेंटम इज आल्सो वेक्टर। इफ यू डोंट अलाउ Vaibhav to talk, you know what happens? I'm literally get scared looking at him. That he makes a face like this. वो कुछ होता है ना, रोमन कैथलिक एक्सोर्सिज्म में पोजेस बच्चा, in the name of the Holy Spirit, the Father, and this, I command you to raise. If you allow him to talk, everything is okay. If you don't allow him to talk, then he'll just see. He's looking at you absolutely blank. Not that he's looking like an idiot to me. I'm literally scared looking two times in. मैं कैसा ना ऐसा psychic look देते रहता है। हाँ। No, paying attention, but that attention is such now. राजीव कल नॉर्थ कोरिया घूम के आया है, समझ में आया? ये चेक भी मारा कर। ये साइड अगर वेक्टर है तो ये साइड भी वेक्टर होना ही है। आप ट्राई करो घर में, प्रॉब्लम नहीं बनता है तो फिर वो यू कैन पोस्ट सर इज स्लीपिंग, सर इज स्नोरिंग। अगर ज्यादा प्रॉब्लम घुस जाएगा, सर विल टेक आउट हिज LMG एंड आई विल कम इनटू द बैटलफील्ड। बिफोर दैट यू ऑल कैन टेक केयर। एटलीस्ट नाउ यू ऑल आर गुड सोल्जर्स। आप खुद लड़ो। ये तो खाली रेडियो करता है वायरलेस, एनी एम्युनिशन रिक्वायर्ड, आई एम कमिंग, है ना? ये बाहर से लिखते रहता है, एनी एम्युनिशन रिक्वायर्ड, ओवर एंड आउट। मैं तो भाई हेडक्वार्टर में बैठा हूं, ज्यादा प्रॉब्लम हुआ आई विल स्टेप इन, बट कीप दैट टेम्पो ऑन। डोंट टेक दैट दिस इज वैभव्स प्रॉब्लम, दिस इज पीयूषा's प्रॉब्लम, दिस इज हर प्रॉब्लम। एक ने प्रॉब्लम छोड़ा, 10 लोग झपट पड़ो उसके ऊपर, गलत होगा, रॉन्ग होगा, देन मेक फन ऑफ ईच अदर। You are calculating this downward, it should be upward. मुझे कितना मजा आया. आपको क्या लग रहा है मैं सोया हुआ था? मैं नहीं लिख रहा था, मैंने वाइफ को दिखाना था मैं क्या लिख रहा हूँ. She is telling me, क्या लिखते रहते हो? मैंने कहा वही सारी snoring. And I showed this to grade 10 people yesterday, humiliating them that the grade 9s work like this. आपके सामने बोल रहा हूँ. My grade 9s work like this. आप ही को पूछना. This is how my grade 9 people work. I'm not happy that they solve the problem. I'm happy that they all know how to collaborate. You don't know how to collaborate. You all can only remain quiet. And please don't let this spirit die in you. As you age up, then slowly you start becoming, तुम्हारा teens में हो ना, तुम्हारा brain थोड़ा ज़्यादा चलता है, जो कि चलना नहीं चाहिए. So there's a very lovely, what you call, there's a documentary,